Thank you, Adil. With slide number 9, I'm going to explain how we chose the most suitable ports in India. This is important because Jewelry Engineering doesn't have a physical power generation plant yet, and this would give Jewelry Engineering a clue to find the proper place to build power generation facility. To identify the most suitable ports in India, we reviewed 3 categories: local accessibility, capacity, and efficiency level of the ports. And we filtered out unsuitable ports based on these categories. Team firstly reviewed local accessibility, focusing on railways, because coal is mainly transported by railways. Our secondary research shows that 13 of major ports have well-equipped railways. This can be supported by the fact that 30% of cargoes handled in major ports are currently transported by train. On the other hand, 8% of dependencies of non-major ports on railways indicates extremely low rail connectivity to the ports. Due to the low rail connectivity, team decided to delete all of the non-major ports from the pool of the potential importing ports, and we decided to go further with the 13 of major ports. As for the next filter, team decided to use capacity available for thermal coal from 2014. Enough capacity must be secured because if there is no capacity available for Jewelry Engineering, all the coal will be stuck in the ports and it will be delayed, and it might cause lots of problems. Based on our secondary research, we found that there are 4 ports which have capacity available from 2014: Visakhapatnam, Haldia, Momugao, and Paradip. As for the last step, we determined the rankings with these 4 ports by the efficiency level of the ports, and found that Paradip is the most suitable ports and the best ports in India. To go further with Paradip, I will explain slide number 10. Paradip is located in east coast of India and have 4.5 million tons of capacity from 2014. You might think 4,005 is not enough because you need 5 million. But when we calculate 4.5 tons of capacity, some amount of coal from new power generation plant are included. So we believe that 0.5 tons of gap between capacity available and capacity required can be disregarded here. And in addition to capacity, Paradip has 125,000 tons of deadweight tonnage, but it will be increased to 185,000 tons of DWT by 2017, which means Paradip can have availability to contain cape size of vessel. So you can get cost benefit, you can get logistic cost benefit from with the bigger size of ships. And now I'm going to explain about the shipping cost with slide number 11. This slide is explaining that what kind of index we used. We used the Baltic Dry Index. Baltic Dry Index is an economic indicator which converts daily average price of 4 different sizes of ships: Handysize, Supramax, Panamax, and Capesize. Considering DWT of Paradip, which is now 75,000, will be 125, at the end will be 185,000. We believe Panamax is the best and most suitable size of ships, because team decided to be conservative to calculate the shipping cost. That's why we want to go to Panamax. Panamax size means the capacity between 60,000 tons and 80,000. We believe this is the most economic size for the Paradip ports now. Based on our calculation, we found that Indonesia has $10.20, and which means the most economic country to deliver from Indonesia to India, and followed by Mozambique and South Africa. Thank you.
Okay, to make a summary of the reasoning behind the coal selection methodology, we started by identifying the major coal producers around the world and coal exporters. Then we moved to identify the markets with the coal quality required by Super Engineer, where we identified that Indonesia and South Africa are the markets that are known for providing that kind of coal. Then we moved to analyzing the consistency of supply, where we identified that it's necessary for the company to balance the risk of non-performance, so they should try to divide its sourcing from at least 2 countries to reduce that risk. And also, the company should overlook of potential reduction in coal exports from Indonesia over the next 10 years. Then we moved to the logistics assessment, where we found that the cheapest option is also Indonesia. Then into the FOB prices, where the spot markets show that the Indonesian coal is the cheapest coal in the market. But anyway, the company should try to look for opportunities in long-term contracts with with suppliers that they can provide lower opportunities to offer lower prices. And finally, potential suppliers. Companies should look to deal with big suppliers, given that they are the only ones that are in the position to make large investments to develop infrastructure projects and reduce the total cost of coal.
With the understanding of logistics options, with Paradip as the most suitable Indian port and Indonesia being the cheapest alternative, we will have a look at the coal trading methods and the analysis of main drivers in coal price volatility. Robin and Burju will take us through this.
Thank you, Adil. Now I will talk about how coal buying is done in international market. Internationally, coal buying is done either through spot markets or through long-term contracts. In this graph, we have compared oil prices with spot coal and long-term coal. So as we can see, historically, long-term prices of coal were higher than the spot prices, and suppliers were very willing to enter into the long-term contracts rather than selling in spot markets. But after 2003, we can see, due to introduction of coal derivative trading in the market, there is sudden jump in the volatility, and due to increased demand of coal from India and China. Since the long-term contracts are mostly cost-based, which is relatively stable, if we just regress the contract price line due to unavailability of coal price details, we can see that the suppliers will get very low prices in cost-linked contracts compared to spot markets. So right now, in the current scenario, suppliers are reluctant to enter into long-term contracts which are linked to cost. So now I will talk about further on what are the different options in the international market in long-term contracts. So basically there are 4 kind of contracts available in the international market which are used widely. First is fixed price contracts. As the name say, the price mechanism is the price is fixed for the duration of the contract. Then there's market price contracts, in which price of the coal is linked to the market based on a negotiated index. Then third is cost-based contract. So here supplier vary the price of the coal as per the cost. And the fourth one, which was historically most widely used, was EPC contract, where supplier give a base price and the price escalates based on an agreed input price index. So if we look at historically, I said historically mostly cost-based contracts were used, or partially cost-linked contracts. 93% from 1980 to 2000, either EPC or cost-based contracts were used. But from our primary research, we can see that suppliers are right now getting more reluctant to enter into such kind of contracts, and they are preferring more market-linked contracts, or you can get some kind of hybrids of fixed-price contracts for short durations. So now I will hand over to Burju. She will talk more about how the spot market works and how we are trying to link the spot prices in a model.
Thank you. At the spot market, the price of coal is determined by demand and supply of coals, and the indication of this balance is coal price indices. Team identified the main indices as API2, Europe CIF, API 4 South Africa FOB, API 6 Australia FOB, ICI for Indonesia coal index. And the next step was to understand their behaviors. So we observed whether they don't differ significantly from each other or not, but they are very close to each other, especially API 4 and 6. And as for the price trend, till 2007 the prices were stable, and for recent years they become volatile. For the huge peak occurs here, the reason was global economical crisis, and recently through the end of the 2010, heavy rains and massive floods in Australia hit coal mining sector at that region. Also, oil export shutdown in Middle East contributed to that change as well. And more recently, in 2011, Japan earthquake bring out the debates about safety of nuclear plants. Also, Merkel government declared last week that they will get rid of all their nuclear plants by 2022. All these dramatical changes occur by unforeseen factors like political and economical development, natural disasters, extreme weather conditions, regulations about labor and environment, also technological improvements.